In this lesson, we are going to use the method of sections for determining internal forces and 2D load condition. The design of any structural member requires finding the forces acting within the members to make sure the material can resist those loads. For example, we want to determine the internal forces acting on the cross-section at B, but first we need to determine the support reactions. Then we need to cut the beam at B and draw a free body diagram of one of the halves of the beam. This free body diagram will include the internal forces acting at B. Finally, we need to solve for these unknowns using the equation of equilibrium. In two-dimensional cases, typically internal loads are normal or axial forces, such as N acting perpendicular to the section, shear forces V acting along the surface, and bending moment M. The loads on the left and right sides of the section at B are equal in magnitude but opposite in direction. This is because when the two sides are reconnected, the net loads are zero at the section. Here are the steps for determining internal forces. Take an imaginary cut at the place where you need to determine the internal forces, then decide which resulting section or piece will be easier to analyze. If necessary, determine any support reactions or joint forces. You need to draw a free body diagram of the entire structure and solving for the unknown reactions. Draw a free body diagram of the piece of the structures you have decided to analyze. Remember to show the N, V, and M loads at the cut surface. Apply the equation of equilibrium to the free body diagram, drawn in 3 steps, and solve for the unknown internal loads. So let's jump into this example in which the loading on the beam is shown and we need to find internal forces at point C. To find the solution, following procedure is recommended. Plan on taking the imaginary cut at C. It will be easier to work with the right section, the cut at C to point B, since the geometry is simpler and there are no external loads. We need to determine By, use a free body diagram of the entire frame and solve the equation of equilibrium for By. The free body diagram of the entire beam is shown here. Now applying the equation of equilibrium to this free body diagram, we get Bx equal to 0. And applying the equation of moment about A, resulting By 6 kilopounds of force. Now draw a free body diagram of the right section. Assumed positive directions for VC, NC, and MC as shown. Apply the equation of equilibrium to this free body diagram. Get following results: NC equal to 0, VC equal to minus 6 kilopounds, and MC equal to 27 kilopounds feet. Thanks for watching.